Welcome to the DIY Honda Garage channel. The DTC P2176, identified as the Throttle Actuator Control System Idle Position Not Learned, indicates a failure in the throttle actuator control system in Honda Fit models from 2015 to 2020. This trouble code pertains to the system responsible for controlling the engine's throttle position, which is crucial for proper engine operation. The throttle actuator plays a significant role by regulating airflow into the engine, thus managing the vehicle's speed and acceleration. Located within the throttle body, this actuator receives signals from the Engine Control Module, ECM, and adjusts the throttle valve accordingly. If this system is not functioning correctly, it can lead to performance issues. Proper diagnostics must be performed to determine the exact root cause, ensuring safe and efficient engine performance. The DTC P2176 indicates that the throttle actuator control system has not learned the idle position. The throttle actuator works in conjunction with the Engine Control Module, ECM, to manage engine air intake. This learning process is critical, as failing to recognize the idle position may result in poor engine performance or even stalling. The throttle body, where the actuator is situated, is located between the air filter and the intake manifold, making it accessible for inspection and service. Understanding the relationship between the throttle body and the ECM is essential, as improper functioning can lead to drivability issues. Identifying this DTC allows technicians to isolate the throttle body or relevant wiring as potential issues in the system. Several factors can trigger DTC P2176. First, poor electrical connections or loose terminals at the throttle body and the powertrain control module, PCM, might lead to communication failures within the throttle actuator control system. Any disruption in these connections can hinder the system's ability to properly learn and adjust the throttle position. Secondly, a dirty throttle body may restrict the movement of the throttle valve due to the buildup of sludge or carbon deposits, preventing accurate readings and responses. Lastly, a faulty throttle actuator itself may be incapable of responding to the commands from the ECM. Each of these potential causes needs thorough inspection and testing to ensure vehicle reliability and performance. The presence of DTC P2176 can manifest through distinct symptoms. One of the most noticeable signs is the illumination of the check engine light (CEL) on the dashboard, indicating a fault that requires attention. Additionally, drivers may experience poor acceleration, where the vehicle fails to respond effectively to the throttle input, which directly impacts overall driving performance. Another common symptom is a rough idle. The vehicle may shake or fluctuate in speed while in a stationary position, leading to an uncomfortable driving experience. These symptoms highlight the crucial importance of diagnosing and addressing the throttle actuator control system promptly, ensuring smooth vehicle operation while preventing potential long-term damage. In the first troubleshooting step for DTC P2176, start by placing the vehicle in the on mode, which enables the vehicle's electrical systems without starting the engine. Next, use the Honda Diagnostic System, HDS, to clear the current diagnostic trouble codes, DTCs, from the PCM. This action resets the system and allows for a fresh assessment. After clearing, turn the vehicle off and wait for 10 seconds. Powering back on to the on mode lets you check for any pending or confirmed DTCs using the HDS again. If DTC P2176 reappears as confirmed, the issue persists, prompting the technician to proceed further in troubleshooting. If it does not reappear, this could signify an intermittent failure, requiring additional checks for wiring or connection issues. For the second step, begin by turning the vehicle to the off position and disconnecting the intake air duct from the throttle body. This step allows for safe access to the throttle assembly without interference from the intake system. With the duct removed, switch the vehicle to the on mode again to activate the electrical systems. Clear any existing DTCs using the HDS to prepare for observation. Now, perform the Electronic Throttle Control System, ETCS. Test within the HDS inspection menu. This specific function allows you to visually check if the throttle valve moves into its fully closed position, which is vital for accurate system operation. If it moves correctly, the technician can proceed to the next troubleshooting step. Any dysfunction in the valve's movement may indicate a deeper problem with the throttle body itself that requires further exploration. In this third troubleshooting step, start by turning the vehicle to the off mode to ensure safety. After this, carefully remove the throttle body from its mounting position. The actuator within must be inspected for buildup that may impede its function. Look for sludge or carbon deposits on the throttle valve, as these contaminants can significantly impact the valve's ability to respond accurately to the ECM signals. If you identify any sludge or carbon, it is essential to clean the throttle body thoroughly to remove these obstructions. If the inspection shows no contamination, professionals recommend replacing the throttle body entirely, as it may still be malfunctioning internally, leading to persistent issues evidenced by DTC P2176. The fourth troubleshooting step involves checking for open wires, specifically in the MTR1 and MTR2 lines linked to the throttle actuator. Start by switching the vehicle to the off mode. Utilize the HDS to jump the short circuit switch SCS line, waiting for more than 1 minute to ensure proper conditions for testing. Next, disconnect the relevant connectors from the PCM and the throttle body. Using a jumper wire, connect the specified terminals on the throttle body 6P connector. Then, check for continuity between the designated test points on the PCM connector. It is essential to ensure continuity measures 1.0 ohm or less to confirm that the MTR1 and MTR2 wires are functioning correctly. If they meet this quality standard, proceed to substitute with a known good throttle body. If DTC P2176 reappears, it indicates a necessary replacement of the PCM. After completing the necessary repairs or replacements, the final step is to verify that the work effectively addressed the DTC P2176 issue. First, reconnect the HDS and recheck for any remaining DTCs to ensure that P2176 is cleared from the system. If the code is absent, it suggests that the problem was successfully resolved. Following this, it is prudent to conduct a test drive to validate that the vehicle operates normally and that the throttle actuator functions as intended. Throughout the drive, monitor acceleration performance and ensure the vehicle maintains an even idle. This thorough verification process confirms that the repair not only addressed the symptoms, but restored the vehicle's performance consistency. To prevent future occurrences of DTC P2176, implementing regular preventive maintenance is critical. Regular cleaning of the throttle body will help remove any carbon buildup that can inhibit the throttle valve's function. This process should ideally be part of an annual vehicle service or whenever fuel injectors are serviced. Furthermore, it's essential to routinely inspect all wiring and electrical connections related to the throttle system, ensuring they are secure and free from corrosion, which could lead to intermittent failures. Updating the vehicle's software is also crucial. Manufacturers sometimes release updates that can enhance the performance or rectify known issues within the ECM or throttle control software. Consistent maintenance of these components will promote optimal vehicle performance and minimize unexpected issues. In summary, diagnosing DTC P2176 requires a structured troubleshooting approach to identify specific issues with the throttle actuator control system. Various potential causes, including electrical connections, throttle body contamination, and the actuator's condition, must be scrutinized to effectively resolve the issue. Each diagnostic step builds upon the previous one, giving technicians a comprehensive understanding of the underlying problems affecting vehicle operation. Furthermore, preventive maintenance plays a crucial role in avoiding unnecessary recurrences of this and similar DTCs by ensuring all components remain in optimal condition. By systematically following the outlined steps and maintaining the throttle system, vehicle reliability and performance can be significantly improved. Please like and subscribe to the channel. See you next time.